Okay, here we go. First we'll find the equivalent resistance of this pair here in parallel, replace it with one resistor, and we do that right here, and we find that that equivalent 1 over the equivalent resistance is 1/2, but to find the equivalent resistance R12 we flip that and we get 2. So there's the resistance of that combination. Then we add this guy because we're in series, so that's 4. So the equivalent resistance of the circuit is 6 ohms. We then find the current through the circuit, that's 3 amps. Now that leaves here, but it's going to split here, so the current through either one of those will not be 3 amps, but their sum will be 3 amps. And then right through here we have 3 amps. So we're going to go over here, and we find the voltage drop across that resistor. Well, it's going to be 3 amps times 4 ohms, 12 volts. Now we erase, and what have we now? We have 18 volts, all right, of energy per charge coming here. We don't lose any through the circuit wire. Let's go over to the right. This guy drops 12 volts, okay, so he's going to subtract 12 volts to get to where? What do we need over here? We need 0 volts because that's connected to the negative terminal of the battery. So this delta V is 12 volts, which means there's 12 volts here, which means for every coulomb of charge there's 12 joules of energy. So what happened to the other 6 volts? They were dropped across these two guys in parallel. So we know we have 6 volts across resistors 1 and resistors 2. They're in parallel. So the current through resistor 1 will be V1 over R1, 6 volts over 3 ohms, we get 2 amps. So we'll have 2 amps through that guy, and if we have 3 amps coming out of the circuit, what has to go through the 6 ohm resistor? Well, that would be 1 amp. But we didn't ask that, but that's just an added on value here.